Welcome everyone, and thank you for joining us today for a webinar about harnessing the power of IoT. This is Ian Purdy here from Crossvale, and with me today I also have Antonio de Laguio Sanchez. You may see Antonio's hand or the top of his head sometime during the presentation, but he'll not be speaking. But John Casala, on the other hand, will be saying a few words towards the end of the webinar about Red Hat and the product set that they have in this space. So let's fire straight into the meat of the webinar. This is what I hope to cover in the approximately 45 minutes that we're going to be here. I'm going to describe an IoT scenario that we're going to demo, and then I'll demo that scenario using a hardware simulator. I'm not sure if any of you recognize Walter White there. You probably didn't realize he also was an elevator technician. And then we're going to do a software simulator demo where you all get to join in. So provided you have a browser, you can contribute to the demo that we're going to do later. Then I'm going to cover a few of the challenges that you may encounter as you attempt to harness the power of IoT. And then we'll talk about some techie stuff relating to the demo and the reference architecture that we're using. Finally, you'll have an opportunity to ask a few questions, and that should hopefully wrap us up in about 50 minutes. Okay. I would like to just say at the outset that although in this demo I'm going to use a particular scenario, which is predictive maintenance of elevators, I don't want you to think that this is limited, that the solution we're talking about here is limited to this or even similar scenarios. IoT can be used in many, many business scenarios today, and actually it's predicted that most businesses over the next 5 to 10 years will use IoT to transform their businesses. And the key message that I want you to take away from this is that you really don't want to miss that boat. So now is the time to be thinking about how you can harness the power of IoT in your business before your competitors do. So although I'm going to use one particular example, if you're from the banking world, you should be thinking about how you might use geofencing. If you're telecoms, you might use this, for example, for monitoring the attenuation in your radio towers. If you service MRI machines, you might be thinking about how you monitor helium levels. If you manage wind turbines, you might be thinking about how you measure vibration and wind speed and so on. So try and think how the principles that I'm describing in this webinar might apply to your business as we go through. Okay, so the scenario, as I said, that we're going to use today is predictive maintenance. So this is a company who services elevators, and they send out a maintenance man to work on these elevators, either to inspect them or to fix them whenever they break down. And there's actually 3 different models of maintenance that are used today. The first one is reactive maintenance, and it generally results in a poor customer experience because you're reacting to a fault. So you already have someone stuck in the lift, they're already shouting help, they're pressing the red button, and you try and get somebody there as quickly as possible to minimize their poor customer experience. But inevitably, it will be a poor customer experience. Some companies have tried to alleviate that by having a preventative maintenance model. So in this case, they look at their stats and they work out how often elevators fail, and they send somebody out to inspect the elevator more regularly than typically they fail. And they do some inspection of components that typically fail and work out whether they need replaced or maybe a little bit of adjustment. This has 2 downsides. One is it's inconvenient because nearly always when you're doing that inspection, then the asset is out of service. And it's also unnecessarily costly because you're sending out a truck, you're sending out an engineer to do that inspection. And very often, there will be absolutely nothing that needs fixed. So it's a necessary truck roll. The third model, which we're going to look at today, is predictive maintenance. Predictive maintenance means that you don't just go out on a routine schedule. You actually monitor the asset and work out when is right time to go out. And you're aiming to go out just before it fails. So not years before it fails or not a few minutes after it fails, but just before it's likely to fail. And that requires careful monitoring and analysis of the asset. And that's where IoT comes in. So this is the connection of assets or anything, in fact, to some monitoring system. And we're going to describe one such system today. In order to work out when you need to do some predictive maintenance, you need to understand what normal is. So what represents normal so that you can then identify when an abnormal thing happens. And in the demo we're going to do today, we're going to look at 4 different things. We're going to look at the position of the elevator in the elevator shaft. So we'll know, for example, is it in a place it should be? We're going to look at the speed at which it is ascending or descending within that elevator shaft so that we can determine whether maybe something's not looking quite right with that. We're going to look at the weight of the occupants or any other equipment that's in the elevator. And finally, we're going to look at the power or current draw of the motor that is pulling up the elevator. The scenario then that we're going to show you has some sensors on the simulator. It collects information on location, power consumption, and so on, we talked about earlier, and sends that to a REST API. That's just a gateway, if you like, into the IoT framework that can accept any sorts of events. So a REST API could receive events about position or weight of occupants or whatever. It'll receive all those different types of events through the same API. And then it sends that into the Acumina framework, which is a cross-fail component built on the Red Hat products that we'll talk about later. It analyzes that data, changing in real time, and then posts alerts as it sees abnormal situations to the service management system. And in the case of the demo, we're going to send those to ServiceMax, which is an industry leader in the field service management space. It's based on Salesforce. So we are integrating our IoT framework with line of business systems in order to not only show graphs of what's happening, but to produce real actionable alerts that can make the customer experience better or can save your business, save costs within your business by reacting more quickly to the events. And then the engineer will either pick up a work order or look at the alert that's come up, and because he knows in advance what the issue is likely to be, he can actually turn up with the right equipment or order up the equipment and turn up in time before the actual fault develops into a malfunction of the asset. Okay, so this is a little hardware simulator we've built. It doesn't look very much like an elevator, but it does something similar. It goes up and down, and at the back here you can see a couple of little ultrasonic sensors. So that's how it measures how far up the elevator shaft it is. We've got some lights on it to tell us when it's sending messages, and a reset button. In IoT, where you're monitoring an asset like this, you very often have the concept of a digital twin, or sometimes called an asset avatar. It's something that lives in the virtual world but represents the thing in the real world, and it can take the form of a picture or some data, but it's trying to convey to a person who is remote from the asset what's actually happening to that asset at any point in time. And here you can see this digital twin shows us where the elevator is, on which of the floors it is, what weight's in it, what the power consumption is, and some details about when it last sent a message and what the IP address is it's using. And then on the back end of that, we have ServiceMax, as I said. I'm showing here a screenshot from the mobile app because ServiceMax has a mobile application, so the engineer can actually get it while they're out and about in the field, or today we're actually going to show you it on a browser window. Now, before we start then, we have to teach this IoT system what normal is. And that, of course, could be done by manually entering those details. So we could manually enter in the position of floor 1, floor 2, and floor 3 up the elevator shaft. But in practice, that's very costly and error prone. So we prefer to use machine learning. So we have the IoT framework monitoring the events that are coming in. In our case, to keep it nice and short, we're saying the first 6 movements of the elevator is going to be the learning period. And during that period, it's making measurements and working out where the floors are and what speed it's ascending and descending so that it knows what normal is. So we're going to jump now to looking at the hardware elevator. I'm hoping on the left-hand side of the screen, you can see my little elevator shaft and the elevator simulator at the bottom on floor 1. And we're going to now move it up and down the floors, stopping at each floor. Because this is all done through manually, if you like, I needed to build in a little bit of tolerance, so it doesn't need to be exactly at the floor. In practice, on a real elevator, your tolerances would be much smaller. But we're going to move this up and down, and it's going to learn the positions. So let's go ahead, Antonio, and move it up to one of the floors. So you can see over here that it's saying that it's in learning mode. It's already worked out what the average ascent velocity is so far, and it's worked out the first floor, for now, is 253 centimeters up. Okay, so let's now move to another floor. So it's now learnt a second floor. Let's move again. So it's learnt a third floor. And we've got 6 of these to do, so just 2 more to go. Okay. And finally, I'm not sure if anyone noticed there, but there was actually a blip where it said connection loss, so we momentarily lost connection. So when we go and look at the alerts in a moment, we should see there was a connection lost alert, I think. So let's keep going, Antonio. Okay, so now you see it's finished its learning period and it's now in running state. So if I go and look in the Salesforce application, I can see that it has now discovered that there is an asset out in the field called Elvor and Stella 1. And when I click on that, I can then, this takes a few moments for it to bring back the details. I can click on IoT events here, and it's telling me that learning's complete, and there's that connection loss that we saw just briefly blip up. So I'm guessing that was a tiny glitch in the network between the device and the back-end system. And we can also look at this on a map. So if we refresh on here, we can see that we've got an asset here in London, and we can see it's Elvor and Stella 1 running. Okay. Now we're going to simulate a scenario where we have a failure. So the first one we're going to do, just bring up a slide here so we can talk about it. The first one we're going to look at is where the elevator stops at an unusual height. So it has learnt what the positions are for the right floors. So if it stops now at somewhere that it doesn't recognize as a floor, it should be able to send an alert. And because it's measuring the weight, it can work out whether there is actually somebody inside. So it can determine the priority of that. So it might be a medium alert if there's nobody inside, and a high priority alert if there is somebody inside. And then obviously the engineers can react with the appropriate level of urgency. So let's now go and simulate that. So now you can see it stopped halfway between floor 2 and floor 3, and you can see up here there's a little red triangle to tell us we've got a problem here, folks. And if I go now to look on Salesforce, I expect to see an elevator stuck, and it's saying there are people inside, and so it's a high priority criticality. And indeed, if we look on the map, we will also see that on there, it's showing the elevator stuck. Now what I'm going to do is show you another couple of potential scenarios that we might have. And the ones we're going to look at is where the elevator is ascending more slowly than it normally did during the learning period, or it's descending more quickly than when it was first installed. So the former might suggest that the motor is becoming less efficient and therefore needs some inspection. It might even be some remote diagnostics, because you don't necessarily have to go on site. Or if it's descending more quickly than it should, it may be that the control mechanisms are not working as effectively as they need to be, so they need some sort of inspection and some maintenance. So let's jump now to simulate these two scenarios. So we're going to go slowly up to the next floor, so that it will hopefully trigger a slow ascent. Look at that. Thank you, Antonio. Average ascent velocity is showing as an alert. And if we now go very quickly to the bottom, we should see average descent. Yo, it's there. And now if we switch off completely, we should see the same connection lost alert that we saw earlier, but this time it will persist because we've switched the elevator off. So now if we go here and do a refresh, we can see our slow ascent, our fast descent, and our connection lost event. Okay, now what I'm going to do is show you this from the point of view of our software simulator, and this is where you can start to get involved. So in this case, instead of having a hardware simulator, we're going to have a little web app that you can move up and down this blue arrow to the different floors, and you can change the number of people, or if you want to stick a ton weight into it, let's say a air conditioning unit that you're taking up onto the roof, or you can change the power from normal power consumption to high power consumption, and then you will see that reflected on the digital twin. And then whenever I give you the URL to do this, you can generate some alerts yourself, and we'll see it coming up on the map where everybody is on the world. Don't worry, it won't go down to house position. We're just picking up on your on using the IP address, so it's not going to give away your position. So let's now go and do that. So whenever I put in this URL, it's going to prompt me for the asset name. Now, so that you can spot your own asset on the map, you might want to change this, for example, to be your email address. It will actually change it to not have special characters, but we can put them in for now. So if I do iPurdy@crossfield.com and hit OK, it takes a few seconds to load, especially the first few that load in. So if you're very quick in and it's running up a pod, then it might take a few seconds for it to load up. Okay, here we are. So here's the simulator, and here's the digital twin. You don't need to be able to read what it's saying on here, but you can see that, or if you may be able to see that it shows my asset ID here, which hopefully is unique, and it's currently in learning mode. So I'm going to very quickly take it through a learning cycle. It's important while you're doing this, whenever I hand over to you to do it, it's important while you're doing this to try and be as consistent in the speed at which you move the little pointer, so as not to generate alerts when you don't mean to, and then do it much slower or much faster when you actually want to generate the alerts. I'll demonstrate that now. So if we go, for example, up to the first floor, we can see that it has learned the first floor. Then we go up to the second floor. It's learned the second floor. We go up to the third floor. It's learned the third floor, and so on. We just have two more transitions to do. Because that one was one it had already been to, it didn't update. So here we've now learned 5 floors. And this demonstrates what I was saying earlier, that I didn't have to configure this to tell it where the floors were. So on the hardware one, we just had 4 floors. Now I've decided the roof is also a floor, so I just move it to there during the learning period, and now it knows that's a valid floor. But if I were to move now to, for example, floor 1.5 slowly, you can see it has come up with the alert. And now if I jump to here, It has identified, ooh, there's other people have already jumped in here. So if I click on this elevator, and click on IoT events, I can see that I've got my learning complete, I've got my elevator stuck, and I've got my slow ascent. So when we go to the map and refresh that, we can see we have a couple here. One's going to be my hardware one, and one is going to be my software one. That's my software one that's stuck, and here's my hardware one that's disconnected. And if I scroll out, oh yes, there we are. Some people starting to appear already. So what I'm going to do now is share in the chat window the URL so that you can start to play with this yourself. So let me just paste that in there now. Antonio, can you confirm that you can see that in the chat window?
I can see it.
Okay, so we're just going to give you a couple of minutes to get to that URL. I strongly recommend you cut and paste it rather than trying to type it in, because if you get a character wrong, it's not going to work. So cut and paste it into your browser address with field, and hopefully you will get your little simulator and you can then play with it to generate alerts. I'm going to refresh this now to see if we can see any more appearing. Oh yes, here we are. And if I click on this one that says 3, it opens out and shows me where they are. One near Hutchinson. We now have a couple in and around Dallas. And if I click on that, that one's learning. So someone's in learning mode there. They're both in learning mode. So we'll give you another little bit of time to do that. So these are just as a reminder, these are the scenarios that you might want to reproduce. So that's the URL. You put in your asset name here, which typically could be your email address or some other unique ID. It will actually default to a random set of characters that should be unique. So if you want to just accept that rather than putting in a name, then that's fine. And then what we're going to look for is the motor drawing more current than normal? Or is the elevator carrying more weight than it was designed to carry? Or has the elevator exceeded the work done threshold and needs a service? So while you're all getting up to speed with that, I'm going to create some of these alerts in my elevator. So if I click, for example, the 1 ton, you can see that I'm getting a weight alert here. And if I go into my here and refresh, I'm able to see that I've got an overloaded alert in Salesforce. If I have too much power, then it's going to flag that as well. Let's put it back to normal. And now what I'm going to do is just do some more movements to try and trigger a service due. So if I do more work done than the service due threshold, then I should see an alert for that as well. We're getting close, 454. There we are. We've gone over the limit, 76,000 kilojoules, and 75,000 was the limit. So if I now do a refresh on here, I can see there's a service due. So that would be a trigger then for the engineer to go out and do some maintenance, some inspection of this elevator, because it has done the amount of work we would expect an elevator to do before it needs some routine maintenance. Okay, let's have a look at the map and see if we've got many more. Oh, I've got somebody in Spain. Very good. And they've got a stuck elevator, so they've managed to generate some. We have some more coming up here in Dallas. and we've got an overloaded event there. So if we were to pick up this one, for example, 9PS, if we go into Salesforce, you can tell from your digital twin if that's the one that belonged to you. If we go into our install products, go to 9PS, I noticed another 25 elevators there, so we've got quite a few people who are joining in. Well done. If we go to we can see this one had elevator stuck, high power, so somebody is really putting this elevator through its paces. Well done. Okay, I think we'll draw a line under it there. I will leave the cluster running for 15, 20 minutes after the webinar if you want to play some more, but I think we should get back to the meat of the presentation. So the next thing I wanted to just talk briefly about were some of the challenges that our customers cite on, when they are discussing how they got on their IoT journey. And one of the first ones they often mention is lack of coordination, because introducing IoT to your business is a bit like a large integration project. It involves typically multiple lines of business systems, involves multiple stakeholders, and everybody's got their own idea of how it should work and so on. So you do need to treat it as a project. You do need to put in place proper project management and treat it like a significant integration project. But when you're starting small, so when you're just doing one small business one, you can obviously scale down the level of your project management, but you still need to do it. The next thing that's often cited is budget. And what I would advise you to do here is to try and avoid an initial high outlay when you're testing out your ideas. When you're doing your proof of concept, you should be able to use an architecture and a product portfolio that doesn't have a huge initial outlay. And this is one of the reasons why we chose open source solutions. We'll go into that a little bit on the next point, but you can start out with very low costs. And then as your idea flourishes, as you realize that it's going to really take off, then you can start to bring in the other, scale it up, bring in more servers and so on. But the costs grow with the size of your implementation. You don't have a very high initial outlay. The third thing I want to talk about is technology. I mentioned that we are advocates of open source, which is why we have Red Hat on the call this afternoon as well, because they are the leaders in the open source for enterprise arena. Some of the advantages of open source are you don't have any vendor lock-in, so you're not locked into any particular vendor. The second thing we have found is you've got unparalleled innovation. Is really the hallmark of open source development, because you've got so many different players contributing to it. The second thing is you've got enhanced security, which is a really important part of IoT, because security by obscurity isn't really security. So you really want to be able to see what's happening in your IoT solution so you can determine if there are security holes rather than finding them out whenever there is a breach. One of the advantages of going with the Red Hat portfolio is that whenever you then do go into production particularly, and you know that you need that enterprise grade support, you've got their award-winning support behind you. The last point I wanted to make under the 4 key challenges was management support. This is really crucial to a successful IoT project, as it is with most projects. And the thing I would say here is that some companies think that maybe we should start with something that's really low risk to try out this technology. But I would advise against that. You want to try and pick something that really matters to the business, something that's going to make a difference if it does work, and also to identify a champion for that. Then someone who is actually going to benefit from this, someone who's going to benefit either from the cost savings or from the customer experience improvement, or indeed from the extra revenue that you're going to generate through your IoT solution. And identify all the stakeholders and make sure you get that buy-in from all those people who are involved. I just want to mention a couple of other obstacles that people have encountered along the way. So one thing is, or actually for getting started, one of the things that sometimes puts people off from getting started is that things are moving so quickly that they would rather wait until things have settled down a little bit, until it's a bit clearer what the best technologies are, before they jump in. I would just caution you that it's unlikely that the rate of change is going to reduce over the next few years. I think it's only going to accelerate. I don't think it's going to be any different from you have today, and possibly even faster pace of change over the next few years. So I would encourage you to get going now while you have a bit of a head start on some of your competitors. The other obstacle that sometimes gets thrown up is that people have already collected mountains of data. They have data warehouses that are brimming with data, but they can't actually get any useful value from it. They can't distill any insights that really help their business. It's just a place that data goes to die. And that is, I think, a critical point when you're starting your IoT solution, is to make sure you understand what data is actually going to benefit you. You know, have a purpose when you're collecting the data, so you don't just collect it hoping that someday it'll be useful to you. And remember that data, the value of data, diminishes over time, so you need to be able to make use of that data and get the insights out of it in real time or near real time to really get the benefits. Okay, having gone through a couple of slides of challenges and obstacles, you might be thinking, this is not for me. I think I'll just run away and hide and come back another day. And I don't want you to go with that impression, because really there is too much. There's too much at stake here. The benefits are too important for you to do that. And the technology is at a point now that whatever your idea is, it is very, very likely that it is possible. So it might look like a veritable Everest that you're facing, but if you can get started and get up to the base camp, the first base camp, things will become a lot clearer. You'll build your confidence in what you're able to do. You'll see more clearly what IoT scenarios are actually delivering benefit, and then you can invest more in those. So I would encourage you to, in fact, I would challenge you to bring me an IoT idea that we can't solve technically. The solutions are there now if you come up with the scenario. I'm going to spend a few minutes just talking through the technical aspects, because there probably are some on the call who are interested in that aspect. So this is the Red Hat reference architecture that we have bought into. So this is a logical view of an IoT solution. So you've got IoT gateways bringing data from the sensors, the connected things, and feeding them through to an IoT integration hub, which manages the gateways and then fires the data on to the engine that does the analysis and the machine learning and so on. And then you would have your enterprise applications, your line of business applications, a bit like the Salesforce one that we had in our demo. So the products that we use in this reference architecture are a couple of open source projects called Cura and Capua. And they're built on top of AMQ, which is a messaging system which delivers the MQTT messages between the devices and the in our case, the Acumina analysis engine. And this combination, these complementary projects work together. So Cura is sending the events, and Capua is receiving those events, but it is also giving you control of the IoT gateways during commission, during in-life management, to make sure that, for example, your certificates are updated, to make sure that the life cycle of that IoT gateway is handled correctly. We use JBoss middleware, and that includes the whole suite of BPMS, BRMS, and Fuse, not only at the back end to manage how we interface with the back end systems, but also in the gateway. So we strongly believe that you should do as much of the analysis as you can at the edge for two reasons. One is it reduces latency on your responses, and the second thing is it minimizes or optimizes your traffic across the network, because you want to try and keep that as low as you can. So if there is some analysis you can do at the edge and summarize your data before passing it on. That's better. And also, your machine learning models can be fed out to that IoT gateway so that it can actually do some of the alerting even from there as well. And if you have middleware on that gateway, it can interface with your line of business systems as well. Cloudera is the reference architecture machine learning aspect, and all of this is built on OpenShift. Now, I'm a huge advocate of OpenShift. It is an absolutely beautiful product based on Kubernetes and Docker, and it allows you to not only use a DevOps approach, which is quite important for IoT, because you want to be continually refining your algorithms as you go forward, as you learn what works for you. But OpenShift also allows you to scale. So you can start off with one pod for your POC and scale up to literally hundreds of thousands without changing any of your architecture. Okay, let's keep moving. This is the Acumina architecture. I'm going to just run through this very quickly. So we have the events coming in from the sensors, going into the ingester, which then stores them in our case, Cassandra. And the analyzer then picks up from that. There's an orchestrator that keeps track of the analyzer so we can automatically scale up as more events come in. We then have an alert processor, which can feed it out to the other lines of business systems. We have the twin reading that information from Cassandra, and the map so that we can see those two GUIs that we saw earlier. In later webinar, we're going to describe how you can have resilience at the persistence layer. We're going to describe a little bit more how we use AMQ, BRMS, BPMS, and Fuse. That we'll cover those on a later webinar because we're going to run out of time on this one. Very quickly, how we implement this on OpenShift. So the previous webinar we did around DevOps, we talked about the master and infra components. So if you've seen that previous webinar, you'll already know about these. I'm not going to spend any more time on this. But what I want to highlight here is we actually have 3 masters. We have 3 infra nodes and we have 3 workers. This gives us the resilience that we want. And you can scale this up further. So you could have literally hundreds of workers. But it means if you lose 1 master or 1 infra, or even 2 masters or 2 infras, you're not actually losing any of your capability. And the same happens with the worker nodes. So on here we have pods or services. So it's like a microservices architecture. We have services for each of the different aspects. I've grouped them together here for simplicity. Okay, very quickly then, an overview of Crossveil. We're established in 2001. We have around about 100 specialist employees, mostly in the US, but we have operations in Europe and in the Middle East as well. Our main focus is around integration and particularly IoT. We've got a lot of experience within financial services, telecoms, logistics, you name it. We do consulting, architecture, development, and training as well. I'm going to hand over to John for a couple of minutes. John, if you'd like to introduce Red Hat and talk a little bit about the products there. If you tell me when to skip on to the next slide, I can do that for you.
All right, very good. Thank you, Ian. So I'm John Kazala. I'm a senior solution architect working with our partner and channel organization. I've been with Red Hat for a little over 5 years. Prior to that, I was in the telecom industry working a lot with IoT and big data. So I've been actually in this space for about 7 to 8 years. One of the things that really impressed me was I actually started working with Red Hat as a customer, so much so that I loved it, that I needed to come and join the company. So Red Hat's a really fascinating place. We've grown to over 10,000 employees. We are in pretty much every position across the globe. We've reached $2 billion and are rapidly growing as open source is really sort of what we say eating the world. Go ahead, Ian, you go to the next slide.
Sorry, John.
So one of the important things that Ian was kind of showing you is a lot of our customers are in this transition from what you see from the top row down to the lower row, going from monoliths to microservices, from a data mart data center into some type of hybrid model, and then moving from a development model based on waterfall into DevOps. This is really key for being pertinent in today's industry as we are all being asked to move faster and faster. And that's one of the great things working with our partners such as Crossveil is that they can help you to make these transitions. And they've been through this and are really experts at helping you navigate these changes across your environment. The next slide, Ian. So what Ian was talking about is what you just saw was all built on OpenShift. OpenShift is our container platform, utilizing Docker and Kubernetes. One of the beautiful things that Red Hat's done is we've taken our complete JBoss portfolio and integrated that into OpenShift so that it runs natively. OpenShift allows you to move your workloads from a public cloud to a private cloud and any mix that you want, because you have a consistent environment that is independent of whatever public cloud you may be building on. One of the key things is that it takes the complete portfolio that we've been building in Red Hat in the JBoss middleware and makes it available across all of these different cloud platforms. Next slide, Ian.
Okay, I think we're now coming towards the end. So this is just a slide to encourage you to please get in contact with us and tell us how we can help you. Before we finally leave you, though, we're going to give you an opportunity to ask a few questions, and I'll hand over to the moderator maybe to let me see if I can see where I can see the questions that have already been entered. Okay, so there's a question there about, is there any manufacturer currently using this technology? So yes, indeed, I have some statistics, for example, from Schindler. They reckon that it has reduced their outages by around 75%, and it has reduced their O&M costs, their operation and maintenance costs, by about 50%. So really significant impact to their business. And you should be able to see similar step changes in your business as well. It's just about identifying the scenarios. I heard one really innovative enterprise just last week at the IoT Solutions World Congress in Barcelona. They were saying that they were feeding their alpacas sensors. Alpacas are very valuable creatures, so they're actually feeding them sensors so that they could track where they were and track their health using these sensors that they had swallowed. Any other questions there? So is there going to be a recorded version of this cast? Absolutely. We will post out a link to it to anybody that has registered. It'll also be available on the Red Hat site if you want to find it there. Another question just popped in. How long did it take us to put this together? So obviously to build the framework it was quite an investment on our part. But now that framework is there, we can put together solutions like this in a small number of weeks. So typically 4 to 6 weeks. The one that we had, someone has just asked, what's the hardest bit of this, of doing this demo? And typically it is the integration with the LOB systems, because you're working with quite complex systems and you're trying to integrate typically with legacy systems as well. But this is Crossfield's bread and butter. So although it's one of the trickiest parts of it, it's not insurmountable by any means. Okay, have you used OpenShift for Cura builds and deploy to Raspberry Pis? Yes, that has been done. So depending on what you want to do on your gateways, you have to obviously choose a hardware that's going to support that. So we can show you this in a future webinar, but you obviously, if you're going to run something like BPMS or BRMS or Fuse on your gateway, you're probably not going to run that on a Raspberry Pi. You probably need something a little bit beefier, but there is no reason why you can't use Cura on a Raspberry Pi. And I think...
And that's Raspberry Pi 3?
Sorry, I missed that.
The question related directly to Raspberry Pi 3s.
Raspberry Pi 3s, yes. So actually, okay, this demo that you've seen is running on a Raspberry Pi 3. Yep. Okay, will we call a halt then? We've run over our time. Did you have anything else you wanted to say, John, just before we call a halt?
Yeah, just to kind of add to the Raspberry Pi question. So that's one of the beauties of Fuse and AMQ is that they actually run fairly well on Raspberry Pi. Red Hat did a demo at our summit 2 years ago that basically did an IoT example where we were monitoring people's movements throughout the facility, and it runs very, very well. That's
Cool.
one of the benefits of it.
Okay, I wasn't aware of that one. Thanks, John. So just before I leave, I would like to leave you with a little taster. So we have already, as I mentioned earlier in the presentation, done a DevOps webinar where we described how you should be moving towards a DevOps culture and how OpenShift supports that very well. This time we've talked about an IoT example. Just to whet your appetite, we're looking at the next webinar covering how to save hosting costs using spot instances on AWS. So at the moment we are running this on an AWS cluster, which, as you probably know, can mount up the cost quite quickly. So we're going to demonstrate how we can get a handle on that. We're going to talk about using Jenkins pipelines for A/B testing and blue-green deployments. We are aiming to have a webinar specifically around AMQ, BPMS, and BRMS for IoT event processing. We're going to look at one for resilience at the data persistence layer on OpenShift, monitoring and alerts using Grafana and Prometheus, and finally security. We'll go into a bit of depth on security. So these are all things we mentioned briefly on the way through, but they really deserve a webinar in their own right because they're quite meaty subjects. If you have other suggestions that you would like us to talk about, please feel free to fire those into us, and we'll look and see if we can add them into our roadmap.